How load travels through a building. Welcome back to Blueprint to Reality, the channel where we turn invisible forces into clear engineering logic. Every building stands because loads know exactly where to go. But how does the weight of a roof end up deep in the ground? How does a person standing on the top floor transfer force to the soil below? Today, we're uncovering a fundamental concept in structural engineering: how load travels through a building. Introduction. When we look at a building, we see walls, floors, and columns. Engineers see something else: load paths. A building survives not because it is strong everywhere, but because loads are guided safely from top to bottom. In this video, we'll break down what structural loads really are, the vertical and horizontal load path, how different elements share forces, and what happens when the load path is interrupted. 1. What is a load? A load is any force acting on a structure. Types of loads: dead load, self-weight of the structure; live load, people, furniture, vehicles; wind load, pressure and suction; seismic load, ground movement forces; snow and rain loads. Every load must travel somewhere. 2. The concept of a load path. A load path is the route forces follow through a structure. The rule: load must move. Roof, floor, beams, columns, foundation, soil. If any link in this chain fails, collapse can occur. 3. Load collection. Floors and roofs. Floors and roofs are load collectors. How they work: loads spread across slabs transfer forces to beams or walls. Diaphragm action distributes horizontal loads. They act like trays, gathering weight and passing it onward. 4. Load transfer through beams. Beams receive load from slabs. Structural behavior: beams bend top fibers, compress bottom fibers, stretch. Beams send load to columns, load-bearing walls. Incorrect beam sizing disrupts the entire load path. 5. Columns and walls. The vertical highways. Columns and load-bearing walls are the main carriers. Their role: transfer axial loads, downward resist buckling, maintain alignment. A missing or weakened column can trigger progressive collapse. 6. Foundation. The final distributor. Foundations don't hold the building. They spread load safely into soil. Types of foundations: isolated footings, raft foundations, pile foundations. Soil-bearing capacity controls foundation design. 7. Horizontal load path. Wind and earthquakes. Not all loads move straight down. Horizontal load flow. Wind hits facade, slabs act as diaphragm, shear walls and frames resist forces, loads travel to foundations. Buildings must resist sliding and overturning. 8. Load redistribution and redundancy. Good buildings share load. Why redundancy matters: prevents sudden collapse, allows alternate load paths, improves safety. When one element fails, others step in. 9. What happens when load path is broken? Broken load paths cause disasters. Common causes: removing load-bearing walls, poor renovations, design errors, construction mistakes. The load doesn't disappear. Finds a dangerous new path. 10. Why every engineer obsesses over load paths. Load paths define safety. Engineering reality. Strong materials are useless without continuity. Design is about force flow. Load path clarity prevents failure. Every safe building has a clear, continuous load path. Conclusion: buildings don't stand still. They are constantly carrying forces. From the roof to the soil, every element has a role in guiding load safely. Understanding how load travels through a building is the foundation of all structural design. If this video helped you visualize invisible forces, like, share, and subscribe to Blueprint to Reality. Comment below: which structural concept should we break down next? At Blueprint to Reality, we don't just build structures, we understand how they stand. See you in the next video.